Thermoforming is the process of applying heat to a sheet material, thereby making it soft and pliable, and forming it using a mold into a usable part. Only thermoplastic materials can be thermoformed. In fact, that is the basic definition of a thermoplastic. It can be softened and change shape when heated and return to its original hardness after cooling. There are two basic types of molds, male and female. With a male mold, a heated sheet is pulled, typically using a vacuum, down over a mold that projects into the part when it is formed. With a female mold, the heated sheet is pulled into the mold and the material projects into the mold. We'll look at examples of both. Let's take a look at a very common machine, a shuttle type thermoformer. You're looking at a mold, in this case a male mold, that will actually make two parts. This is commonly called a two-up mold, meaning that the mold will create two parts at the same time from one sheet of material. The sheet, which is black reprocessed high-density polyethylene, is loaded into the shuttle. The clamps close to hold the sheet in place while it is being formed. It moves into the oven, then is heated to forming temperature. In fact, you can actually see the sheet sagging from the heat softening the material. The sheet is then shuttled to the mold and using a vacuum formed into a semi-finished part. As you can see, the actual forming of a part, once the sheet is heated to forming temperature, is a pretty quick operation. Once the part is cooled sufficiently to remove, these parts will need to be separated. That's what the operator is doing here, using a bandsaw to cut the two parts apart. These parts, which are components of a school bus wheel well, are now ready to go to the next process, which is 5-axis router finishing, as you saw in the routing video. It is very common to produce parts in this multiple part arrangement, and it is not unusual to see 4 or 6 or even more parts being produced each time a sheet is formed. The size and shape of a part usually determines how many you will form at one time. Multiple part tooling and forming improves efficiency and productivity, taking cost out of the process. Here you see a rotary type thermoformer. The primary difference between a shuttle type machine and a rotary machine is the way the material is handled. A rotary machine has multiple stations in a circular layout, somewhat like a carousel, that allows for a sheet to be loaded at one station, while at another station the sheet is in the oven being heated, and at a third station a part is being formed. The material being formed here is talc-filled recycled black high-density polyethylene. Rotary forming substantially increases the efficiency and productivity of the process. Rotary type machines are more suited for larger quantities of parts than are shuttle machines. Thermoforming molds, or tooling, are very cost effective. They are typically much less expensive than injection molding tooling. That is one of the key benefits to thermoforming, the tooling cost. And large parts like the one you see here are very difficult to injection mold, and the cost of the tooling or mold could easily run into hundreds of thousands of dollars. This thermoforming mold cost about $12,000. It is made from aluminum, and several thousand parts can be produced on such molds due to their durability. Many different kinds of parts, from very small to very large, and from very simple to very complex shapes, can be produced using the thermoforming process. The yellow part at the top is a tractor fender made from TPO, which is thermoplastic olefin. The yellow part on the right is a headlight bezel that surrounds the headlights on a school bus and is made from ABS. The bottom part is a component of a passenger aircraft armrest and is made from a fire retardant FAA compliant Kydex. This is a dashboard for a school bus, and in this image you see the glove box that will be inserted into that dashboard. This is a part that is used to house electronics on an aircraft, again made from fire retardant Kydex. Every Piedmont branch has customers that thermoform plastic parts. Like with most types of businesses, they vary from very small companies that might operate one thermoforming machine to very large companies that may have several or many and that offer added services like assembly and decorating. Thermoforming is used in various industries, from sign manufacturing — here's an example of a thermoform sign — to transportation, as we've seen examples of in this video, to just about any kind of industry. The thermoforming operations you have seen here were all performed at our fabrication division in Charlotte, North Carolina. We have extensive and very high quality thermoforming capability here. We also do thermoforming in our Denver, Colorado fabrication facility. Now let's take a look at some more fabrication processes in the next videos.